I'm Alex Balog with Basking Filter. We are from the University of Oregon, and I just graduated with my master's in architecture.
I'm Ben Cooper. I graduated from the University of Oregon with an MBA this past spring, and I'm the second half of Basking Filter.
I was an environmental engineer before I came back to school into architecture, and while I was studying architecture, I was taking a class called biomimicry, where I found out research about filter feeding animals like basking sharks who have a self-cleaning, anti-clogging fluid dynamic principle, and was really just inspired to kind of push the idea and see how far it could go. And then Invent Oregon really just came in along the process as I was working with the University of Oregon's entrepreneurship department and starting to get more into the business side of things.
Although I was pursuing a finance specialization in the MBA program, I took a lot of entrepreneurship courses just to get a more rounded business education. And I was in a class called New Venture Planning with Nathan Lilligard. And Alex came into the class looking for a partner once, and I thought, well, someone else will do it. And then he came in again, pitching his idea, and I thought, well, no one else said they wanted to join, and I had some prior experience with the kind of problems he was trying to solve around wastewater and stormwater, and I thought, okay, I have some experience with this in my previous career as a winemaker. It sounds like an interesting idea, and so I reached out to him, and we hit it off, and we've been working on it since November when I joined.
From a lot of different perspectives. So at the very beginning of this journey, I was able to use some of the lab space that the energy studies and building lab that we have here at the University of Oregon. They let me use some of their equipment. So that was really able to just give me a general feel of, and then the Entrepreneurship Center has just been really great in terms of connecting with people such as Ben and getting a partner on board and really starting to focus and develop more of a market strategy as opposed to just here's a cool design.
So at least in the business school, there are 4 centers of excellence, and we have a finance center. We also have an entrepreneurship and innovation center. Nathan Lilligard runs that along with Kate Harmon, and both of them have been great resources to get help from, and just providing a space for entrepreneurs to meet, putting on these entrepreneurship dinners. In addition, Nathan is an entrepreneur himself who's launched a business from the University of Oregon, and having someone who's gone through all this before to come and talk to him about what we're trying to do, what our strategies are, and that's probably the best resource that we've availed ourselves through the University of Oregon.
March, right before all of the lockdown, social distancing, and what have you, we were able to get funding to get our prototype, and so we were really excited about that. But then just the process of everything since then, just communications and everything is really slow. So we're just really anxious to finally see our prototype in a couple of weeks here.
A lot of challenges figuring out how to keep our momentum when the shelter-in-place order was enacted. We were supposed to get the prototype started earlier, but then everything came to a screeching halt. So we've just learned to adapt to the situation and how to carry forward and try to rebuild momentum. That's probably the biggest lesson that we've learned, one of the biggest challenges we've overcome.
Basking Filter is a self-cleaning filter based on filter feeding fish. This is sort of the abstracted design, which is a helical filter. So it's a filter that could be used for a wide range of solutions, but really its main advantage is that it's going to keep the membrane, the geometry, in use for longer than typical filtration systems could, with less maintenance.
Using the amazing adaptations of the basking shark, the idea is that it has a special proprietary internal cone, and our cone sits inside of a pipe and water flows through it. And because of a special fluid dynamic that's created, water is filtered and then separated, concentrated the effluent in its own stream, and then clean water is allowed to continue on in the cleaning process or to be discharged. And that allows companies to reduce their operations expenses in addition to using fewer filters, spending less time maintaining, fewer headaches.
A smaller scale like we're talking about, it's going to make on-site waste treatment and sustainability, at-home sustainability, more attainable. So things like gray water systems and reuse within the home. So I think this is a piece of technology that's going to enhance that reach of that type of technology. But then at a larger scale, if you start thinking about industrial scale and things of that nature, you could really sort of change. Processing happens because if this thing could keep the life of membranes longer and you are spending less time maintaining, in theory, you can produce more. So it kind of shifts the balance of production waste management.
And the idea is we want to make wastewater treatment more affordable and more available, and also address the problem of wastewater in the United States as well as around the world. The more water that you can recover and recover quickly after use is something that can be very beneficial going forward.